Okay, we've got another question here about inverse functions and specifically about their domain and range. Remember, domain is the x direction and the range is the y direction. Let's have a look at it. Okay, the normal procedure for finding the inverse is to set y equal to our function. So if I now square both sides, I get y squared is equal to x plus 3. And therefore, rearranging everything, x on its own is equal to y squared minus 3. Now we swap, and using the function notation again, we get that f to the minus 1 of x is equal to, swapping this to an x, this becomes x squared minus 3. So here's a plot of what's going on. This is our original curve, the curve of the square root of x plus 3. Now, the reason this doesn't continue down here is because the lowest x can go, and it can equal it, is negative 3. Because if it is, I'm asking to do the square root of a negative number, which itself is impossible. When x is negative 3, this becomes 0. And the square root of 0 is 0. That's possible, which is why this curve starts at 0 and starts to climb. With this restriction, our quadratic of x squared minus 3 is restricted to positive values of x. So for fx, the domain is that x is greater than or equal to negative 3. And the range, well, the range are the y values, which will go up from 0 up to infinity. So y is greater than or equal to 0. Now let's have a look at the inverse. F to the minus 1 of x, its domain, which are the x values, is that x must be greater than or equal to 0. And the range, well, the range of the y values, is that y must be greater than or equal to negative 3. Now, just as the lines are reflections of each other in the line y equals x, our 45-degree line, look what's happened to the domains and the ranges. They've also swapped over. What was a domain for the function becomes a range for the inverse. And what was a range for the function becomes a domain for the inverse. And that's a useful rule to remember. Let's have a look at part B. So let's first of all put this on a common denominator of x minus 2. This will simply be 3, but we must multiply the 2 by x minus 2. And this will be equal to 3 plus, multiplying the bracket out, that'll be 2x minus 4 divided by x minus 2, which is equal to, putting the 3 and the negative 4 together, we get 2x minus 1 on the top and x minus 2 on the bottom. And this, remember, is y. Okay, now if we cross multiply and try to make x the subject, we get y. X minus 2 is equal to 2x minus 1. Multiplying this out, we get yx minus 2y is equal to 2x minus 1. Gathering up the x terms and put them onto the left-hand side, we get x. Y minus 2 is equal to negative 1, and it's joined now by a positive 2y. So therefore, x is equal to 2y minus 1 divided by y minus 2. And therefore, f to the minus 1 of x, now our swap from x's to y's, we get 2x minus 1 over x minus 2, which, if you look at our two results, are one and the same. So whatever we work out for the domain and range of the function, the same rules will apply to the domain and range of the inverse. So we've got that fx is equal to 2x minus 1 over x minus 2. Now, how should we restrict x in this expression? In other words, restrict the domain to stop this expression going crazy. Well, the one value of x that will make this expression go crazy is 2. Because if we have x as 2, the numerator is okay, but the denominator is 2 minus 2. So you're dividing by 0. So as far as the domain goes, x must not equal 2. Now again, what value of y, remember fx effectively is y, that would also make this expression go mad? So again, if we bring back y temporarily and cross multiply, we get x minus 2 is equal to 2x minus 1. So therefore yx minus 2y is equal to 2x minus 1. Have a look at these two terms. If y was 2, these two terms would disappear. And if they did disappear, and y was still 2, I would get the nonsense statement of negative 4, because remember y is 2, is equal to negative 1. So as far as the range goes, y must not be allowed to be equal to 2. And because fx is actually equal to f to the minus 1 of x, these two restrictions also apply to f to the minus 1 of x. So we can say that their domain and ranges are the same. And that will be your answer.